Okay, welcome to our new lesson on flipped classrooms. We're going to start today with a little bit of a warm-up. Do me a favor, take a few minutes and see if you can decide which vocab word, not dependent, dependent, consistent, or inconsistent, best fits the description over here. So take a few minutes and see if you can decide what that might be. And as you can see here, first you need to decide if the solution is consistent or inconsistent. Does it have no solutions or at least one? And if it does have at least one solution, does it have exactly one, not dependent, or does it have infinite, dependent? Alright, good, nice little warm-up. Let's continue on. Here is the following system of equations: inconsistent, consistent, and or dependent. In order to solve this, you need to determine how many solutions there are. Let's look at our train of thinking here. First, we need to decide if they are consistent or inconsistent. And then, if consistent, is it dependent or not dependent? Take a few minutes and decide here. Okay, let's identify the slopes of each of these lines. In this first one here, I am going to solve for y. Put it in the slope-intercept form, so I'm going to divide by 2 on each side. 2/3 cut in half becomes 1/3. 10 cut in half becomes 5. So I have a slope of 1/3 and a y-intercept of 5. In this other equation, I'm going to go ahead and use red for this one. I get 3y is equal to x plus 15. Divide by 3. Y is equal to 1/3 x plus 5. Same slope, same y-intercept. These are exactly the same line. It means it's consistent, and because it's the same line, it is dependent. Alright, infinite solutions. Moving on. Okay, as you could see here, the slope of the first line is 1/3 and the y-intercept was 5. And when solving the other line for slope-intercept form, I identify the slope as 1/3 and the y-intercept of 5. They are the same line, so these are the system of equations is consistent and dependent. Okay, and let's move on to the next slide. Here's another warm-up problem. Can you graph the line y equals x plus 3? Okay, in order to graph the line y equals x plus 3, let's first recognize the y-intercept as positive 3. So we have the y-intercept, I'll put that in red. That's positive 3. Generally we know that as the b value. So we can go 1, 2, 3 and put a point right there. And then I have a slope of, well, the coefficient of x. The coefficient of x right now is a 1. So we have a slope of 1. So that means we have a rise of 1 and a run of 1. And then I can put another dot and then a rise and a run. And I can keep going. I could even go up 1, 2, 3, 4 as long as I go over 1, 2, 3, 4. So all of those generally dictate a slope of positive 1. I'm going to use my line tool and put the line in here that matches y equals x plus 3. Now I should have an arrow on both sides, so I am going to go ahead and just draw that other arrow in. There it is. There's the line y equals x plus 3. Very nice. Now what else do I want you to do here? What would you do if I said graph the line y is greater than or equal to x plus 3? Well, you graphed the line y equals x plus 3, and so all the solutions for the line y equals x plus 3 are along our line. But what about all the values where y is greater than or equal to x plus 3? Well, we're going to need to do some shading. We're going to need to shade half of the plane, either the upper half or the lower half. And in order to determine which half we shade, we kind of just pick a point and plug it in and see if it works. let's pick a point right now. Let's pick the point 0, 0. So I'm going to pick the point 0, 0. If 0, 0 makes the inequality true, then I will shade the half that has 0, 0 on it. However, if 0, 0 gives me a false statement when I plug it in, then I will have to shade the other half of the line. So let's see what happens when I plug in 0, 0. I will go with, where's my marker? Pen, too much work. Alright, so is 0 greater than or equal to 0 plus 3? Is 0 greater than or equal to 3? No, I don't think so. Therefore, I will shade the other half of the line. And I'll use crayon. So there's the solution set that satisfies the inequality y is greater than or equal to x plus 3. So what is the solution to y is greater than or equal to x plus 3? Well, it is every single ordered pair that belongs to the shaded area. So there are an infinite number of solutions that we cannot list, so we just display it with a shaded section of our coordinate plane. Similarly, let's talk about graphing the line y equals negative 2x plus 6. Let's go and use let's go with a fancy color. Let's go green. Yeah, 'cause that's fancy. Nice pea green. Y equals negative 2x plus 6. Our y-intercept is 6. So 1, 2, 3, 4, 5, 6 on the y-axis. Right, this is the x-axis. This is the y-axis. So my slope is negative 2. So that means I can go down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Or I could have gone up 2 to the left 1. Up 2 to the left 1. And I'm going to draw the line that goes through this. Now a negative slope, we should have the line that falls from left to right. And I think that's what we get here when we take a close look at it. Put the arrow back on the end. And there's the line y equals negative 2x plus 6. But we're learning about inequalities. So what about graphing y is less than or equal to negative 2x plus 6? Well, I could still use the same point. I could still test the origin. It's a real nice point to test because 0 and 0 are easy to plug in. So let me test that. Ooh, I need my pen back. Alright. Is 0 less than or equal to negative 2 times 0 plus 6? Is 0 less than or equal to 6? Yes, indeed it is. So I am going to shade the half of the plane that contains the point 0, 0. So all of this right here would be my solution set. All the way up to that line, and including the line. All the points on the line are part of the solution set as well. Do you know what the line would look like if it were not part of the solution set? Interesting. We'll touch on that later. Well, again, the solution would be all the points in the shaded region and beyond. It also continues all the way over here as well. Alright, next, let's get to the actual lesson for today. 4.7, system of inequalities. Not system of equations, system of inequalities. So, here's a system of inequalities. Here's a system. Here's one inequality. Here's the other inequality. So how would I solve this system of inequalities? Well, I'm going to graph the first equation. and then I'm going to graph the second equation. I'm going to shade appropriately, and then the intersection of the solution shaded areas would be the actual solution set for this system of inequalities. So let's go ahead and do that real quick. These are the two problems we already did. So let's go with blue for equation number 1. Y is greater than or equal to x plus 3. So x plus 3, there's 3, slope of 1. So I'll just put a couple points on here, get my line tool, and put my line on here. Alright, I'll come back and put the arrow on in a second. Let me shade that with crayon. Let's go blue crayon on the shading. Alright, so this solution set in blue represents the solution to y is greater than or equal to x plus 3. Let me do it again. I'll go red for equation number 2. Y is less than or equal to negative 2x plus 6. 3, 4, 5, 6. Negative 2, so down 2 over 1. Oh, there's the point of intersection. If these were equations, that would be my solution right there, that point. Alright, let's put this on here. Alright, let's draw the arrows back in. There's the arrow, there's the arrow. I need to shade. I need to shade the less than or equal to negative 2x plus 6. So here's a red crayon. Let me shade all of that. So everywhere in red is the solution to the inequality less than or equal to negative 2x plus 6. But I'm interested in solving the system of equations. Therefore, the solution to my system of equations would be, let's get creative here, and let's make everybody happy. Here's my solution set, including the lines. The lines are part of the solution set. So all of those ordered pairs in the intersection area represent my solutions. Alright, I had written this note out, but the paper it was written on burned, and now I can't make out exactly what it says. Can you please fix the burned lesson and explain what is being said here? Alright, so let's see if you took enough time to see if you can figure it out. And how do I figure this out myself? Can I erase it? Oh, I can. Kinda. What does it say? What does it say? Alright, I guess we'll have to talk about that one in class. On to the next slide. Key question. What is an easy point to test? Pause now and write it down. If you solve for y and the inequality is y is less than 3x minus 4, do you shade above or below the line? You could test a point. And how many solutions does the inequality x plus y is less than 1 have? Well, it's an inequality. That should give you a clue. Okay, let's see how you did. Alright, 0, 0, below the line, and infinite. Don't forget, when the inequality does not have the equal to sign, that's when you make a dotted line. Here's a tricky one. X is less than 1, and x is greater than or equal to negative 4. Go ahead and give it a try, and then you can see how I did. Okay, here's the line x equals 1 right here. Here's the line x equals negative 4. This is dashed because it's not equal to underneath. This is solid because it is equal to underneath. And I shaded everything in between. Alright, try this one. Okay, y is greater than 4. Dashed line shaded above the horizontal line. X minus y is less than or equal to 3. Solve for y. Don't forget to flip the inequality symbol. Graph that line. Shade above. And then the intersection of the blue and the red, or wherever it's purple, would be our solution set. Here's your last one.